right, Algebra 1 people, so we are getting ready for your test. So this test review is online. It's pretty long, so I would not expect you guys to print it. But I would definitely advise listening to this video, and if you do have a printer and want to print it, you can. I'm just going to coach y'all through these problems. So first thing we want to look at, notice the instructions are not on this, but basically you're just supposed to match the graph with this parabola. So, I mean, if you have a graphing calculator, that could help you. But the most beneficial way to make sure you got the correct answer, because sometimes your calculator cannot give you an accurate answer depending on what the window's set at, is to just find your vertex. Notice all of these have a different vertex. So, or even a different axis of symmetry. No, these have the same axis of symmetry, okay? But these two don't. And so, we can eliminate one immediately from this group. Which one immediately can I eliminate? And I would ask you this, and you would say B. Why can I eliminate B right away? It's because it's going down. All these are going up. And if my A value is a positive number, not a negative number, we know we're going to be facing up. Okay? So I'm just going to find my vertex for each of these. So I know this is A, this is B, this is C. And my formula for vertex, which you're going to need to know for your test, is negative B over 2A. Okay, so go ahead and commit that to memory. But I'm going to do negative 8 divided by 2 times my A, which is 2. So this is negative 8 over 4, or I'm running out of room, sorry, negative 2. So guess which one? Right now, I know my axis of symmetry, just by that, it's got to be negative 2. Now, is this at negative 2? No, that's at 2. This one's at negative 4. This one, ding, 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 is our winner, okay? Our axis of symmetry is at negative 2. So you may have to, with some of these, find your y value as well. And so if that was the case, I would plug the negative 2 back in and find your y value. But if I know this is our axis of symmetry, and that's the only one with an axis of symmetry of negative 2, then there you go. That's going to be my winner. Okay, so I'm going to do these others pretty quick. Do the same thing, negative B over 2A. Alright, sorry, that's crooked. And so we know this is A, which is 1. B is negative 6, and C is 10. I'm okay with you writing it like this, but make sure you're including the negative with your B, okay? Because the negative of a negative will give me positive 6 over 2 times 1, or 6 over 2, which would be 3. Okay, and I'm going to look at all these. Okay, that has an axis of symmetry of 3. This one also has an axis of symmetry of 3. This one has negative 3. This one has 3 as well. Okay, so we're probably going to have to find our y value for this one. Okay, so I'm going to plug it in. So instead of anywhere I see x, I'm just going to plug in a 3. So I'll have 3 squared minus 6 times 3 plus 10. This is 9 minus 18 plus 10, which would give me, says negative 9 plus 10, which is 1. Okay, so we're looking for something with a vertex of 3, 1. Okay, so y'all see what I did. I used my formula. I plugged in my negative B, which is positive 6, over 2 times 1, which is 2, which is gave me 3. Then I plugged the 3 in, and I got 1. Okay, so this one's at 3, negative 2. This one's at 3, negative 3. This one's at 3, 1. Oh, yeah, that one looks right. Let's check this one. This one's at negative 3, negative 2. So this one can't be it. This one can't be it. This one can't be it. So it's gotta be B. Okay, which should be correct, right? This is the only one with a vertex at 3, 1. All right. I'm gonna try to make it through this whole video. But I may have to, like, my phone only has a certain amount of storage, so I may have to stop it and then have 2 parts. But I'll try to do the best I can. Okay, so again, I'm going to look at these. Now I can eliminate b right away. We didn't do that for the last problem, but there's one you can always eliminate by just seeing this negative sign. Okay, I know this is, since it's negative out here, these are all going to be pointing down. Okay, so it can't be the one that's pointing up. All right, so I'm going to look at this. My vertex here is -2, -2. Here, it's -4, 4. And this one's at 2, -2. Okay, so look, all our x values are different. So that means all I have to do is find the x value, or my axis symmetry, and I should be good to go. Like, I could be able to figure it out from there. So I know this is A, this is B, this is C, this is -1. So I'm going to use my formula, x is equal to -b over 2a. I'm going to plug it in. And again, this just becomes a +8. Two negatives make a positive. And then this would be -2, so -4. So I'm looking for the one that has -4 as my x value. Okay, look at that. C has the x value of -4. All right, so let's go on down to this next one. Okay. All right, and again, this is just the same type of problem. So I'm just going to plug that in. This is A, B, and C. -b, which is -12. Negative of a negative, it gives you +12 over 2 times 2. Be 12 over 4, which is 3. Okay, and I normally would look at these real quick. We can notice this is at -1, 1. This is at 3, -1. This is at 2, -5. And then this is at -2, -5. Now, I actually did some extra work I didn't need to do. If this is a positive number, I'm going to cross out this first one because we know it can't be pointing down. So it's got to be one of these three. Oh, y'all can't even see what I wrote. Sorry. Oh, too far. Okay. Sorry, my stand. I'm still figuring this thing out. Okay. Okay, this is good. It's going to get right now. All right, so we know we have to look for one with a +3. So notice this had a -2, this had a 2. This is the only one that had a +3. Okay, so if y'all missed it, because my camera wasn't including this part, I just found the vertexes for all of these. So I would go in and do that when you're looking at your test. Okay, so I know since this is my only one with an x value of 3, I know it's C. Again, if there were like 2 of these with the x value of 3, I would have to plug in this 3 for x and then solve for y. Okay, so it'd be 3 squared, which is 9. 2 times 9 is 18. Make sure you do order operations and square before you multiply. Okay, I see so many people multiply before they square, and that does not work. Okay, follow PEMDAS. All right, so let's go on to the next page. All right, so these should be a little easier to do. Why? Look at what form they're in. Yay, vertex form. So we can know the vertex immediately. Okay, again, we want to see which ones can we eliminate. All right, right now, since this is a positive value out here, where I don't have a -2, okay, it's a +2. I know my graph's got to open up. So it's got to either be this one. Okay, it can't be that one. Can it be that one? No. Can it be that one? No. So we can immediately know, right, this, which it works out, this is 3, 1, which should be our vertex, okay, is A. Okay, so that is my answer. Sorry, somebody's coming in my door. All right, so then my next problem that I'm going to do, again, I'm going to use my process, the way I'm going to be thinking through these, right? If I have a positive number out here, I know my graph's got to be pointing up. This one isn't as easy because I can't cancel any of them out. They're all pointing up, okay? So I'm going to use my vertex. I know my vertex is going to be the opposite of what's inside my parentheses, and I'm going to keep the sign of what's on the outside. So my vertex is -2, -1. Okay, so my vertex for this one is -4, -4. My vertex here for this one is 2, 0. My vertex for this one is negative 3 comma negative 1. And my vertex for this one is negative 2 comma negative 1. Okay, so this one is the one I'm going to use. Okay, because all these do not have a vertex of negative 2, negative 1. Oh, and again, y'all cannot see my work. Sorry about that. Okay, so negative 4, 2, 0, negative 3, negative 1, and negative 2, negative 1. This is the only one that works, that has a vertex of negative 2, negative 1. Okay, so I'm just going to work through these problems. They're exactly the same as those last ones that we did. Okay, so again, I'm going to look through these. Okay, this is a negative sign. I know I'm going to be pointing down. All of those are pointing down, so that doesn't help me. All right, but I'm looking for a vertex of 1 comma negative 3. Now this one, I'm not even given an exact point, but I know this is probably 1 because it's in the middle of 0 and 2. So this is 1, and this has got to be negative 3. So 1, negative 3. So this one could be it. So don't get rid of that one. This one is 1 comma negative 1. This one is negative 1, negative 3. And so notice this is a distractor. Do you see that? Because this pretty much, they didn't switch the sign for this one. They just kept it the same. So that's a common mistake people make. So don't assume that C is the correct answer. Right now we're still rooting for A. All right, and this one is negative 1, negative 1. So A is my correct answer. So just because it looks like it's in the middle like this doesn't mean it can't be an answer, okay? You can still be using 1, which is in the middle of 0 and 2, and negative 3, which is in the middle of between negative 2 and negative 4. All right, then I'm going to look at this last one for the graphs. Okay. I know my vertex for this one would be the opposite of what's inside my parentheses. I'm going to keep what's on the outside, which is 1, so my vertex has got to be negative 4, 1. Okay, so I'm going to look at here. This is it's going up by 2's. So this has got to be negative 2, negative 1 for this one. Then over here, we know it's got to be negative 5, and it's down here at like 25. So that's probably not going to be, or negative 6, more like. Okay, so this is probably not the right answer. So I'm probably just going to cross that one out. Then looking over here, this is negative 4, 1, yay. Okay, so it's probably going to be C. Let's go ahead and check this one just to make sure. This is negative 2, 4. Okay, so that one can't be it. So C is the correct answer. All right, so another part of your test is going to be labeling a picture like this. Okay, so basically you're going to label it. The line going down the middle of my quadratic is called the axis of symmetry. And this is all vocab, so this is just all memorization. So you're just going to have to memorize this. Now we look for where these arrows are pointing. They're pointing to the 2 points where my graph crosses through my x-axis. So we're going to call these x-intercepts. Okay, and we can also call them roots or solutions or zeros. So it could be any of those. I might just have them all listed on the test and it'll just be matching, but that's what you call those. Okay, and then we're passing through our y-axis. This is called our y-intercept. And then y'all know this one, that's our vertex. Okay. All right, so I'm gonna look at these. Okay, so this is another type of question that you're gonna have on your test. It's asking for the vertex, okay? So this is gonna be a lot of work for this first problem. So I'm just gonna kind of draw an arrow over here and work it out. So my A value, there's a negative in front of my x, it's just negative 1. My B value is negative 4, and my C value is 3. So I'm going to use, again, my formula x is equal to negative b over 2a. I'm going to plug in the b, plug in a, and so this is 4 over negative 2, which is just negative 2. So that's my x value. So to find my y, I'm going to plug, I'm going to go ahead and rewrite the equation over here so you can see it. I'm going to plug negative 2 in for x. So be really careful when you do this. Make sure you're working using your order of operations. So first we're going to do negative 2 times negative 2, which is positive 4, times the negative 1, which is going to be negative 4. Negative times the negative would give me positive 8, and then plus 3. So I'd work this out. This will become 4 plus 3, which is just 7. So my vertex would be negative 2, 7. Okay, so I'm going to write that over here. Negative 2, 7. And then everything else from there should be pretty straightforward. So my axis of symmetry is just the x value of my vertex, which is negative 2. Make sure you write it as an equation. It's going to be wrong if you just put negative 2. So it has to be x is equal to negative 2. Then my y-intercept is just the c value over here, which is 3. So I would just write 0, 3. Right? Or also take 3 as an answer. All right? So either one of these. And then I'm going to look up here. If I have a negative sign in front of my a value, I know it's going to be opening down. And then remember, down max, so we are going to have a max. Okay, if our quadratic is facing down, we have a maximum for our vertex. All right, here's another one. Okay, so this is just like the last problem we did. I would say go ahead and try this one on your own. Pause the video, try it, and then I'm going to work through it. But, okay, so pause it, and then I'm going to do it. Okay, so my a value is 2, my b value is 20, my c value is 40. Okay, so I'm going to use my x is equal to negative b over 2a. This is negative 20 over 2 times 2, which is my a value. This would be negative 20 all over 4, which is just negative 5. I'm going to plug this x value into my equation, which is this. Okay, so make sure, again, you're using order of operations when you're doing this. Don't do 2 times negative 5, then square it. No, we square first, then we multiply. So this is negative 5 squared, which is 25. So I might go ahead and write that out. 2 times negative 5, or 20 times negative 5 is negative 100. And this is 50. So this would just be negative 10. Put that in your calculator. So my vertex is negative 5, negative 10. So I'm going to write that up here. So again, axis of symmetry has to be x is equal to negative 5. It can't just be negative 5. All right, then the y-intercept is just my c value, which is 40. Or I can write as 0, 40. I look out here, since this is a positive number, I'm going to be opening up, so I'm going to have a minimum. If it helps to draw a picture, you can draw a picture, and notice your vertex is your lowest point, so it's going to be a minimum. All right, now we're going to move down to our vertex forms. These are a little easier, less work. Okay, so my vertex, immediately I can look at it and know, okay, I'm going to take the opposite of what's inside my parentheses, so that's 4. I'm going to keep what's on the outside, so that's 7. My axis of symmetry is just here, so that's x is equal to 4. Does it have a vertical stretch or shrink? So I'm going to look at this 3. Okay, this 3 is greater than 1, so I'm going to have a stretch. And then since it's positive, there's no negative out here, we're going to be opening up. And since it's opening up, I'm going to have a minimum. Okay, so that one was a little faster. All right, we'll go down here. Okay, so my vertex, again, we're taking the opposite of what's on the inside. So if it's a negative or positive 6, it's going to be negative 6. And then I'm going to keep what's on the outside, which is negative 8. So my axis of symmetry is just going to be x by my vertex. So that's x is equal to negative 6. I'm going to look out here, not at the sign, but I'm just going to look at this number. If this number is less than 1, we're going to have a vertical shrink. So since it's 1/4, we're going to have a vertical shrink. And then if I have a negative sign out in front, it's going to be open down, down. We have a max, so it's the max. All right. last, oh my gosh, it's the last page. Okay, so in behavior, this should be super easy for you guys. We've done it before. Basically, if my quadratic is pointing down, my answer for both these blanks is going to be negative infinity and negative infinity. Basically, as it's going to the right or to positive infinity, I'm going down. As I'm going to the left, I'm going down, so that's why both of these are negative. Move down here. If my arms are pointing up, guess what's going to be here? Just positive infinity and positive infinity. Okay. Alright, so for this last one, you may use your calculator for this portion. I don't have a calculator with me that's smart like that. So what I'm going to do is I'm going to always, and this is what I want y'all to do on the test too, you always want to label it like this. Whenever a quadratic looks like that, we're going to label our xi's like this: -2, -1, 0, 1, and 2. So that's just immediate.